This is a Special Forces training facility in Western Australia. Marathon Robotics uses state-of-the-art robotics technology to give users of facilities such as these the opportunity to train with unprecedented levels of realism and unpredictability. These robots allow training with complex motion for long durations.
This is an armoured, mobile target training robot. The advantage of this thing is that it has the smarts to be able to drive itself. So the idea is that one operator can control a fleet of these things by designing a game scenario on a computer and then hitting the go button, and these things will run around the environment, moving in and out of buildings, into and out of line of sight, in a way that's realistic and unpredictable from the soldier's point of view. The way that it works is it has a laser scanner down here that looks out a slot in the armour, and it has a set of navigation algorithms that match what it sees against what it knows about the environment from a map that it built earlier. And since it knows where it is, it can transmit this information in real time using these wireless Ethernet antennas back to a control station, so the operator can see where all the robots are in real time and can interact with them, can give them new paths so they can go react to what the soldiers are doing.
The robots are able to move along any path the user chooses. They can turn on the spot, move in tight circles, and execute quick changes in direction. Rather than remaining bolt upright, the robots lean to accelerate, just like a person. This makes them challenging targets. Their size and physical capabilities are similar to a person's. They can accelerate quickly and stop at any time. The robots can navigate in tight spaces, into and out of buildings. When a robot moves out of line of sight, it's difficult to predict when or where it will reappear. Unlike systems based on rails, there are no constraints on the scenarios the user can design. Fast and unpredictable motion makes it a challenge to keep track of the robots. Following the robots for a long period of time requires a high degree of alertness and concentration. No matter how many robots are involved in a game, they are always able to sense and avoid each other. They communicate amongst themselves to coordinate their behavior. Regardless of the path robots are ordered to follow, they are able to react quickly to avoid unexpected obstacles. They can deal with unexpected situations by planning new paths in real time. Minimal operator workload is required to execute a game. Simply push a few buttons and let the game begin. There's no requirement to use a joystick. The operator can sit back and watch the robot's progress on the screen. This allows a single person to operate the robots for hours at a time. Infrastructure requirements are minimal. The training area only has to be fitted out with wireless Ethernet and a few strips of reflective tape to add navigation. With no infrastructure constraints, instructors can design new scenarios every day to keep people on their toes. The entire system can even be transported to a new location. Since the robots don't rely on cameras to navigate, they have no problems operating at night. Their robust design permits training to continue in adverse weather conditions.
We're ready.
You ready, Chip? Yeah. Okay.
When one robot is hit, the others react by scattering and running for cover.
So what we have today is a realistic, flexible and scalable system for providing high-quality training for urban warfare. In the future, the system can only improve. In addition to scattering after a shot, you can imagine all sorts of unscripted behavior. For example, rather than following a precise script, you could have the robots intelligently execute high-level instructions. For example, you could tell one robot to act like a hostage and another robot to act like a terrorist. Another great addition would be to have the robots detect soldiers' motion and to react appropriately. Since the robots are smart and aware of their surroundings, the possibilities are endless.